Hello and welcome to yet another YoungWonks podcast. Today's topic is going to be alternating current and direct current, or AC versus DC. And I'm your host Suchin, who's going to talk to you about this. As usual, we're all going to focus on the core fundamentals and just try to understand these topics as they are in their very basic format. Right now, getting right into it, the as the name suggests, alternating current is is basically the term used for current that constantly keeps switching its direction. Right now, these are actually the most prevalent form of current that you see around you. Um, Alternating current is used to power the heavy electronics that you see around you. Could be like a ceiling fan, it could be a refrigerator, uh, could be even a washing machine, and many other such things that you will see. Most of the things that you plug into a wall socket, the current that is available to you in the wall socket is alternating current. We'll look a little more into what the advantages of this are, but basically the way it works is that the waveform that you will see when you try to put this on a graph is that the current is sinusoidal. What does that mean? What does that mean? Sinusoidal is like a wave. It increases in one direction up to a maximum, and then it starts decreasing and continues to fall further in the opposite direction. And you'll see that going into the negative half and then come up to zero, and just keep repeating this over and over, over and over, over and over, right? And that is what is called alternating current. We will look at what this looks like as we go ahead as well. But as a fundamental, alternating current is a power supply where current keeps switching its directions periodically. And if you were to look at it on a graph, you would see it as a sinusoidal wave. Now, direct current. Now, direct current is where current flows in a single direction and the electrons move from higher potential to lower potential. And this is something that is very popular when it comes to electronics. You will see that it is used in phones, it's used, let's say, in your TVs, and you can see watches, and most of things which are use battery basically work on direct current. But there are other things which you would use sort of a phone charger sort of thing, which would plug into the wall socket, and that would actually convert alternating current to direct current, and you can use that for your electronics. So now we'll just get to, so this one is direct current, and you can actually see that everywhere around you, the phones being one of the most biggest examples, but nowadays you see that also in everything else. Even light bulbs, which traditionally used to be AC, are now LEDs, which are DC. Now let's look at the comparison. Now, first of all, you see the symbols. AC in a circuit is represented by a circle, and it has a sinusoidal wave or a sine wave on it. Whereas direct current directly mentions plus or minus. The reason being, if the direction of the current keeps changing, you can't actually say which one is positive and which one is negative. Right? Whereas in an indirect current, this is known. The one side has higher potential and the other side has lower potential. Right? Now, why do we need them? Can't we do with just one, AC or DC? No. Both of them have their specific applications, and both are important for us to live the life that we do in the way that we do and use electronics and other equipment in the way that we do. AC is best suited for sending or generating and transferring power over long distances. DC works well within your house, but if you start trying to transmit DC over long distances, it's going to have a lot of loss. So it works best over short distances. AC is useful. For example, you might have seen these big towers that the electrical lines come through and the poles on your street. AC allows power to be generated in one corner of the city or the state and then be transmitted over multiple distances over high voltages. They can get distributed over a grid to multiple destinations. They reach your houses, and in your house, many things work on AC, and whichever things require DC, you can convert your AC to DC and use them there. It's also easier to produce AC. So, for example, the way AC is produced by many different ways, but mostly you can use, so generally you will see coal power plants or hydroelectric power plants, and all of these basically use the energy from the source to move a conductor in and out of a coil, which in turn produces, or sorry, not a conductor but a magnet inside and outside a coil, which in turn produces the AC current, and the motion, to and fro motion of the magnet through the coil produces the current over here. Now, although it is easy to produce, it's not very easy to store. It is best delivered over power lines immediately, because if you store AC, you will think about it. You try to charge a battery and then you charge the negative end for half the cycle and then positive end for half the cycle. The net result is zero. Whereas using DC is possible when we want to store it. You can actually store it in batteries in the form of chemical energy by increasing the density of electrons on one end. Now, AC can be easily converted to DC, so it makes sense for us to use its abilities for easy production and transmission, while DC is safer in a way because the voltages are very low and cannot harm you as much as AC. You got to be very careful about the wall sockets when you do AC. So these are a few things that are comparisons between the two, and which are the reasons why we use one and the other in the places that we do. Now, if we will look at the graphs, you can see on the left we have a battery which is connected to an oscilloscope and a voltmeter, and you can see that. Okay, I'm going to show this to you on the. Yeah, look at it over here. This should be in the ammeter mode. You can see on the left that the current is just flat, right? On the left, it's just flat because so it's just flat because it's just going through and it has one stable current value all throughout. On the right, you see AC power where you can see a sinusoidal wave, and it has the value 50 hertz at 10 volts. That means that you can see the scale is 20. So the top, this is 10 volts positive and then 10 volts negative, and it keeps switching between the two at 50 hertz, or that means it switches from positive to negative 50 times in 1 second. Now, this varies from country to country, but most of them are in this range. In America, for example, we use 110 volts at 50 hertz, right? Now, the other most important thing for us is conversion. Conversion from AC to DC is called rectification. And as you can observe on the graph, you have AC power going in, and these symbols you may recall from our previous episodes. These are called diodes. So a diode connected in like a parallelogram format, and a capacitor to hold charge allows you to convert AC to DC. Let's take a look at this. Now, what you want to observe is initially the current is not directly, or the voltage is still building up. You can see the voltage building up. That's due to the capacitor being charged. And once it is charged, you can see that the output is stable, the LED is on, and this allows you to convert the AC going in DC. Right? So just to recap the concepts that we've learned, AC is alternating current. Here the current keeps switching direction back and forth. Then we have DC, which is direct current. Here the current just flows from the high potential to the lower potential. AC is also useful, very useful and prevalent around us. It is useful because it's easy to transmit over long distances. It is also easy to convert to DC, and on the DC side, it's safer because it has lower voltages. It is easy to store in batteries, and then we look at the conversion and we can see how there is a sinusoidal wave going in and then there's a DC going out. So we get both, best of both worlds, where you can have AC power easily being supplied with low loss to your home, and in your house you can choose to use AC for the devices that need AC and DC for the devices that need DC, right? So that is it. As usual, we always look at the fundamentals, and that brings us to the end of this podcast. Stay tuned for another topic in the next week. If you have any questions regarding this, go over to youngwonks.com/podcast, and I'll be more than happy to address them. This is your host, Sachin, signing off. Thank you.